why, explain, give a little detail, why the radius of sodium ion is smaller than the radius of an oxide ion. Okay, what do I do here? I say, oh, they just chatted about sodium and they just chatted about oxygen. No, they didn't. They chatted about chlorine. So don't get confused thinking that question 1 and question 2, or part A and part B, are necessarily talking about the same things. So do what I just said in the previous question. Begin with drawing. Sodium, ion, nucleus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oxygen, nucleus. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oxygen. That's too many electrons for oxygen, Nicola. Let's try again. There we go. 8. Now, this is a sodium atom. This is an oxygen atom. The question's not about atoms. The question is about ions. So I add my extra electrons to my oxygen. This is now an ion. I take the extra electron away from sodium. This is now an ion. When you do that, when you draw it, you will see these are the same. These are exactly the same electronic configuration. One of them doesn't have more electrons than the other. One of them isn't bigger in terms of number of shells. They are exactly the same electronic configurations. The only difference between them is to do with what is in the nucleus. Now, sodium had 11 protons and 11 electrons to begin with, and oxygen had 1, 2, 3, 4, 5, 6, 7, 8 protons, 8 electrons to begin with. That means that we've got 8 positive charges in the nucleus of the oxygen, and we've got 11 positive charges in the nucleus of the sodium. Sodium's got more protons. If sodium's got more protons, it's going to pull harder on the same amount of electrons. So more protons in sodium ion. And the reason that it's smaller is because those more protons are spread out across exactly the same number of electrons. Okay, not more, not less, but the same.